Hey robot makers, how you doing? Hope you're having a good day so far. So have you got a new Raspberry Pi Pico and you want to see 10 more projects, ideas that you can build with it? Then this is the show for you. So let's dive straight into it. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get straight over to it, shall we? So here's 10 more Pico ideas, because we did a show, I think we had 18, 20 projects in the last show. So here's 10 more ideas. So here is the lineup as of November 2024. We have the original Pico, the Pico 1. We have the Pico W that has the Wi-Fi and Bluetooth module. Then we have the Pico WH, which has the little header pins on it. I grab one of those. So you can see that is the Pico, and it has these little headers built in, so you don't have to do any kind of soldering or anything like that. We also have the other variant, which is the Pico H. So that's the original Pico, but with also the headers on there as well. And then most recently we had the Pico 2, which has the 2350 chip on there. So it's much faster, quite a bit more RAM, and the same number of pins in the same form factor as the original one, but as a dual core, so you can either run the RISC-V Hazard 3, or you can go with the original ARM Cortex, is it M33? We'll get over to that in a minute. And as of yet, we haven't got the Pico 2W launch. I'm sure we will promise that by the end of the year, but there's a couple of weeks left yet, so fingers crossed on that one. So the original RP2040, this was the ARM Cortex M0 Plus running at 133 MHz. It comes with 264K of SRAM, has 30 multifunction GPIO pins, including a 4-channel 12-bit ADC, that's for analog to digital conversion, and a heap of standard peripherals. So we've got I2C, SPI, we have UART, PWM, clocks, etc. We can even do some fancy programmable I/O as well. So that's one of the most interesting features of this generation of chip, and I'm not sure that any other type of chip has this, so it's quite unique to Raspberry Pi, and it means we can offload certain tasks that require high speed transfer rates or precise timing that would traditionally require a lot of heavy lifting from the CPU, so our CPU can be free of all that kind of stuff. And then we have the new RP2350, which is used on the Pico 2. So that has the ARM Cortex M33, which is a dual RISC-V Hazard 3 processor, or you can use the dual. You can use either one of the cores, or both of the cores, or none of the cores. It's quite crazy that the way that they've set this up. It comes bundled with 520K of SRAM, 26 general purpose GPIO pins, and 4 can be used for ADC. And we've got 2 UARTs, 2 SPIs, 2 I2C controllers, 24 pulse width modulation channels, which is pretty awesome, 1 USB 1.1 controller, and we also have the 12 times programmable I/O state machines, which is really awesome. The really cool thing about this chip as well is it comes in 2 sizes, the A or the B chip. The A is the standard one that comes on the Pico 2, so that's the A size chip, and then there's also this B size chip, which comes with a stonking 48 GPIO pins, 8 ADCs, and 24 PWMs. So crazy. So let's have a look at 10 projects to get you started. So these are aimed from beginners and up. So starting off with, if you want some general ideas, if you head over to kezrobots.com/ideas and then click on the Pico Ideas channel, you'll see all the projects that we're looking at today. But I've made that even simpler. I've got some shortcut codes to make that easier for each individual project. So here's the projects that we'll be looking at today. So we've got blinking lights, that's where it all starts, the hello world of physical computing. We've got the temperature sensor, we've got WeatherBot, which is sat next to me just here. We've got BurgerBot, scroll some text with the unicorn hat. We've got Pico graphics, so you can draw pictures, shapes, text, and so on. A birthday card. This is based on the birthday card that I made for Alex's 21st birthday. And we have Pico Cat, which is the open cat variant, a plant monitoring system, driving some LED strips, and just because I like to be awkward, we're also going to have a bonus Pico stands and enclosures as well, so we can look at that. So blinking lights. So blinking lights is probably the first physical computing project that most people have a go with, and it's simply how do you turn on and off either the onboard LED or an LED that's attached to one of the GPIO pins. It's really simple to do, and I've made a nice shortcut link for you to look at there. So if we go over to kevsrobots.com/pico01, let me do that right now. We can get that up on screen and see what that's all about. So I'm just going to click over here. If I just hit return now. So this is actually on the Raspberry Pi's own website, the project's raspberrypi.org, and they've put together a really nice, straightforward, simple project so that you can, if you look, we've kind of jumped right to the blinking onboard LED, but on here we've got how to install Thonny, how to install the latest MicroPython firmware, how to use the shell, and then this jumps straight into how do we actually switch on and off that onboard LED. You can see there the code is pretty straightforward. So from the machine we import pin, which is the pin library, and then we create a variable that's called LED. We set that equal to the pin, and we're going to use pin 25, which is the actual onboard LED, and that's the case for the Pico Ws and Pico 2, I believe. I think the original Pico, no, I tell a lie. That 25, I think, is the pin out for all of them. You can use an LED in brackets for the LED pin on some of the variants. We set that to a pin.out, and that says that this pin is going to be used for output rather than input, because we're going to be flashing a light, that's an output. And then LED.toggle simply changes the value from a 1 to a 0 or a 0 to a 1. It just flips whatever it is at the moment. And if we were to run that code, we would see that the LED would turn on. Now, if we want to make that turn on and off, what we need to do is just add a little bit of extra code in there. So we can have a blink function. We can say, let's set a timer for 2.5 seconds. We can do LED toggle, and then we can init the timer, and we can say, basically every 2.5 seconds it'll turn on or off. It'll do that until we reset to the Pico. So we can actually do some other code in the background, and that will carry on. So that's one of the simplest projects that you can do, and I encourage everybody who has a Pico to try that out because it's very straightforward. You can actually use the onboard LED, which is just at the very top of the Pico there. Might be easier to sort of show you the large version. So the LED would be at the very top right there, and we can simply switch that on or off using that code there. So that's how we get started in programming on the Raspberry Pi Pico in MicroPython, which is the best language for beginners. So next up we have the temperature sensor. So did you know that every single Pico has a built-in temperature sensor inside? And we can use this to read the room temperature in Celsius, Fahrenheit. And again, I've got a nice, easy shortcut code for you. If you go to kevsrobots.com/pico02, we can have a look at how to do exactly that. So let me just jump back out over there, and let's go to Pico02. Oops. Pico02. There we go. So I've actually created a mini course for this one, just so that you can get a little bit more out of it. So very similar to the Raspberry Pi style courses, it'll take you through how to set up Thonny, how to install MicroPython, and then understanding the onboard temperature sensor. So the onboard temperature sensor is actually attached to one of the ADC, one of the analog to digital conversion pins, and we can read the value from that pin and get the current temperature. Now, it's not strictly the room temperature, it's actually the temperature of the CPU, but if the CPU is in the room and it's not working too hard, then it will be pretty much bob on to be what the room temperature is, maybe plus or minus a degree. And we can see on here, this course will teach you how to learn the basics of ADC, how to read a raw value from the temperature sensor, how to convert that into a human readable temperatures such as Fahrenheit or Celsius, and then we can format that for output, we can format that for our screen. So I'll quickly show you what's involved in this. So here we go, we have a sensor ADC, machine.adc4, so pin 4 is where our temperature sensor is connected to. Or ADC4. We can then read in that raw value, and we're in a while true loop, so this will run forever. We can read that in as an ADC read U16, so that's an unsigned 16-bit integer, which is a value between 0 and 65,535, something like that. So it'll be a range of values between that. And that's not a temperature. We need to do a little bit of conversion to make that into a temperature. So that's how we read the raw value. We can simply say print raw value is raw value, and then we can sleep. Now, if we were to run this code and put our finger over the actual CPU, the main chip on there, you'll see that the temperature values will rise, even though it's not a temperature yet. It's just this value between 0 and 65,535. So if we go to the next page, we can then convert that to temperature. So we can say temperature equals 27 minus the raw value minus 0.706 divided by 0.001721. That should get us the Celsius value, apparently. So you can see there, we can also do a bit of conversion. We can convert the ADC to a voltage if we wish. We convert that voltage into a temperature, and then we can print that temperature to the screen. So that's how we can actually get the Celsius value out. And we can add some timestamps to this as well. So we can get the we can use the time library. We can import that time library. We can then do the usual kind of things. We can say timestamp equals time.localTime, and then we can print out. And these look pretty esoteric, but this is how we can use the timestamp.tm hour, timestamp.tm minute, timestamp.tm second, and then the actual temperature as well. And that will give us the formatted output that we're looking for there. And then finally we can enhance these temperature readings by adding some visual separators. So you can see there, if we do print dash times 30, that will create a separator line 30 dashes long. So this is some of the useful things we can do with a print statement there. So we can simply say print the dash 30 times, print our nice formatted output, print the dash 30 times, and then we will see that in progress. So if you want, we can actually try that live now. Let me grab the right connectors so that I can plug in a Pico. So I'm just going to grab, this is a, let's go for a Pico 2. Let us connect this up. So I've got my Pico 2 connected up. I'm just going to plug this in. And then I'm going to load up Thonny. So this is now saying, should I allow this to be connected to my Mac? I'm now going to load up Thonny, and I'm also going to grab that code that we have just on screen there. Let me just grab that. Okay. So if I now load up Thonny, let me grab that there. Let us create a new page. Let's paste this in. And then let's run this, and already we have a bit of an issue. Pin doesn't have ADC capabilities, so I would have to quickly Google what that one is, because off the top of my head I can't remember what on earth the temperature one is. So Pico temp ADC pin. I'm sure it was 4. Yeah, it is number 4. That's weird. Let me try a different Pico instead, in case it's a kind of which edition of the Pico this is. So I'm just plugging in the original Pico version and trying that instead. This is live, so these kind of things can actually happen. Let's stop that. Looks like, I think it was because I was actually running on CircuitPython and not, there we go, let me just install that. So I'm just quickly installing the latest firmware of MicroPython onto this Pico H. Yeah, the issue I was having there, you can see at the bottom it says CircuitPython, so that's why I was having an issue with that. They do things slightly differently over there. Right, so now if I just hit stop, we now have MicroPython. That looks better. Let's run this. And TM hour, it's not happy with that now, so let's get rid of the timestamp part, and then let's just run this as it is. There we go. So we've now got 20.96 degrees, and that sounds about right. I've got the air conditioning in this room set to about 19 degrees, so it's more or less right. Now if I hold my thumb over the processor, you can see now the temperature is rising. It should get to my kind of body temperature if I hold this down long enough. And I'll let go, you'll see that temperature now will drop again. There we go. And we can also do a couple of other things in Thonny. If we get rid of those, we comment out, or just get rid of those lines, and then let's just run this again. Now that we've just got temperature, we should be able to put this into the plotter. So let's do that. There we go. So just by going to view and plotter, I can now hold my thumb down on top of that, and let's see if we can get that to move a bit more radically, and you'll see that plot will adjust based on that size. So this is cool. Every Pico has a temperature sensor built in, so that means we can build all kinds of automatic room temperature sensing type programs with a single Pico without any extra hardware. Cool. So next up we have the WeatherBot. So if we want to take this to the next level, we need a sensor that can do some more things. So WeatherBot, I'll show you this. I have a WeatherBot just here. This is a robot I made quite some time ago, and you can see that it's got on its stomach a little servo, and the servo horn is currently reading whatever the temperature is in the room. What I will do, I'll plug in a battery pack I've just got here into this one, and it should do a little jig with that. So it just takes a second or two for this to sort of fire up, and his head does come off a little bit. There we go. So you can see that little servo horn, and then in a minute it'll go to the middle. There we go. So that's now reading about 20 degrees. The very middle is about 25 degrees. And what's happening now is there's a little temperature sensor. That's a DHT22, and we can use that to measure the room temperature. We can also measure the humidity, so how much moisture is in the air, the air pressure, and we can display all those different things in a number of different ways. Now, if we use a Pico W that's got the Wi-Fi, we can then also send those values to something like an MQTT broker. If you don't know what that is, we've done many shows on that. We can then put that into a database like Influx, like we did last week, and Grafana, and we can map those values as well. So I've got a number of different sensors like that around the house, pretty much one in each room, to measure the room temperature of all the different rooms. And that means we can then track that kind of long term to see what the trends are, which room is hotter and colder than the other. But this is really fun because we have that temperature readout using the servo. So it's kind of a novel way to show what the current temperature is. It's a really simple project to get up and running as well. So let's go over to our browser again. Let's go to number 3. And we should land on the WeatherBot. So WeatherBot is the project here. So you can see we've got a video dedicated to WeatherBot. You can watch that at your leisure. And you can see this works. It was originally designed for the ESP8266, just because I had one of those knocking around. But it runs fine because it's just running in MicroPython. This will work just as well on the Pico or the Pico W. So Pico will just be, it'll just show you the values on its stomach. The Pico W means we've got the Wi-Fi capability. We can then send that out to other areas. So there's 2 STL files. There's essentially just the body and then the head, and we can input what the your current SSID is for your Wi-Fi and your password for your Wi-Fi. And if you have an MQTT server, you can put that in there. You'll just need to copy both the MQTT .simple and weatherbot.py to your Pico and run the code from there. You can see here we've got some this is from the slides from the show that I did on this. We can attach the DHT22, which is the temperature, humidity and pressure sensor. We can connect up a servo, a nice simple SG90 servo, one of the really cheap ones. We can put that in just in the middle there and screw it in place, and then we can attach the servo horn after we put the sticker on there. So I even provide the little sticker that you can print out and stick to the front of that with just some like the kind of glue, that PVA glue that you get in schools, that kind of stuff. And then in the back you can put whichever microcontroller you've got. You can put an Arduino, but in this case it's a Pico W. And yeah, we then simply just connect those wires up. We only need to connect 3 of them to the pins on the back, and we'll be up and running. So how these actually work, we've got 3 pins. We've got a voltage because we have to drive this with some power. 3.3 volts is more than enough to drive this. We need a ground to return that complete the circuit. That's what I'm trying to say. And then we have a data pin as well. So the data pin is how we grab the readings from this sensor. We just read them in. With the servo, that's very similar as well. There's a signal pin, the orange one. There's a voltage and a ground, and we can also connect them all up to the Pico as well. So on that one, this was about how to do this with the Node MCU. But if we flick over to our slides here, I prepared one just the same. So there's the slides that we've just looked at. There's the servo horn. There's the microcontroller, the Pico that goes in the back. There's the head that goes on top. And then there's the temperature, humidity and pressure sensor. These are great. They're very, very cheap as well. And then the wiring diagram, so this couldn't be simpler. We connect up the DHT22, voltage can go into the 5th pin down on the right hand side, which is the 3.3 volts out. We can connect the ground to the ground that's just above that, so this pin here, pin 38, can go to the ground on the DHT22, and then the signal pin for that can go into pin number 4, just to keep the code the same as what we've used on the ESP32 or ESP8266. And then the servo signal pin can go into pin 2, and that needs to be driven by a bit more power, so if you plug that into that system pin there, you've got 5 volts, and similar, we can plug that into any of the grounds, but I've just plugged it into that one just there. And then we can just run the code. Now there's the sticker. I created this nice kind of old-fashioned style WeatherBot sticker, and when I created this, we were called smarsfan.com because I was a very big fan of the Smars robot. But yeah, you can very quickly calibrate your sensor. And yeah, the robot's very, very simple. I used Fusion 360 to design this, and the model is separated into 2 pieces, the body and the head, just to make it nice and easy to use. And we simply just push in the microcontroller into the back. There's a little slot where that can go, and then the DHT22 simply slots into the hand so we can hold the sensor. I quite like that physical element to this robot. It makes it that much more fun. And we can even dashboard that, so we can send those readings, like I said, to MQTT. If you have an MQTT broker, they're very, very easy to set up. I would recommend Mosquito. You can run that on a Raspberry Pi or a Mac or wherever. And then we can send those readings to Node-RED. Every Raspberry Pi used to come with Node-RED installed, but if you've not got that installed, you can do sudo apt install Node-RED and you'll get up and running in no time. It's a great interface. You have these little noodles you connect to all the different nodes that are in there, and we can simply build a little dashboard to show what the current value is as well. So that is the WeatherBot. So next up we have BurgerBot version 2. So on the original 18 projects for your Pico, we looked at the BurgerBot. Now we have got the updated version of BurgerBot that has the pen, so we can put a Sharpie in there and we can have it sort of draw things like so. So that pen can go on the page and draw. Just put that back in. I'm getting full of red ink now. And I quite like the mechanism on here. You can probably just about make out on there. There's like a little rack and pinion type thing going on. So that little servo will simply just move that pen up and down just by moving the servo up and down. Very, very simple mechanically. And we have a Pico in here, and the Pico has got some extra add-ons to make this robot really complete. So we have one add-on which controls the motors. There's a motor shim, and there is also a LiPo shim, so that we can actually charge a LiPo battery that goes just in the back of the robot. I've not got it plugged in at the moment. We can simply put a little LiPo battery in the back there to power the robot. And then on the front of the robot it has this ultrasonic rangefinder, so it can actually see what's in front of it, and we can use that in our projects as well. So it's a very, very simple robot to 3D print. It's even generic construction box compatible. You can see those little studs on there. So yes, Lego compatible. And this is an upgrade from the previous version that had the Pico just on the very top. So it's now completely upgraded. And the reason that the pen is right in the very middle is because if we move the motors in any direction, we can keep that perfectly aligned, and therefore we can draw things just by using that centered. If it was at the top of the robot, that would make it really difficult to sort of draw things, whereas with this it's more like logo. So that's Pico project number 4. So we go over to here and hit number 4. It'll load up the how to build a BurgerBot course that I created for this very thing. So you can see there, back in July I created this this project, this course, and this takes you through everything that you need, all the different parts that you could, if you want to play along with this. So the motor shim from Pimroni, there's the LiPo shim, the little metal geared motors that drive this, the moon buggy wheels, the LiPo battery, which is called a gallium battery, and then the SG90 servo to move the pen up and down. And of course you need a Sharpie as well. You'll probably need a whole bunch of M2 and M3 nuts and bolts as well. There's the numbers of that: 14 M3, 6 M2. So that's about £48 to build this. And of course a 3D printer with some filament to print it. And you can see there I've got a little video that you can watch about what BurgerBot is and why I created it. You can see I've got 3 of them lined up there. I built a whole load of these. I've got a fleet of them. I think there's about 7 of them knocking around the studio. And you can see there the 3D printed parts. We've got the base, we've got the motor holder, the rangefinder, the rear support, battery holder, and the top section. So if we get back to our keynote, I think I have some slides on this. So these are the upgraded parts. The LiPo shim simply just goes on to the header pins of our Pico, and it goes right where the USB connector is, I believe. It just sort of slides over the top. We can then solder that in place to make sure it doesn't go anywhere, and that means we can connect up a battery that's got the JST style connector on it, JST PH I think it is, and that will provide the power for the Pico and for the robot. And it also means that if we plug in a USB cable, we can actually charge that as well, I believe. The Raspberry Pi Pico W means that we can use the Wi-Fi connection on there, and there's that little Galleon 500 milliamp hour battery, LiPo battery from Pimoroni. I think they only ship to the UK. I have to check Pimoroni for that. So I moved the Pico off the top of the robot into the side, and inside the robot, and it's kind of at the back where all the gubbins is. So we've got the battery on one side and we've got the Pico on the other. So this is now the Pico holder. It's really compact design, and it's kind of weighted so that the robot doesn't rattle too much. One of the great things about this is it doesn't require any extra caster kind of wheels. It's got these little fixed casters, as I call them, these little studs. That just mean that it just has those 2 motors and it sort of stays upright. Works fine for kind of desktop use. And yes, there's the Pico in place, the Pico holder. You can see the motor shim is on there as well. And just underneath that motor shim is the LiPo shim. So that has all the connections. You can see the LiPo battery. The wire is coming underneath the Pico, and then it can just slot underneath that this area just here. This is where the just about make out the edge of the LiPo shim there, and this is the motor shim that has 2 connectors on it, one for the left motor, one for the right motor. And this gives us all the room that we need for the pen mechanism. So you can see there we've got the hole for the pen to go through, and this has been designed to work with kind of Sharpie pens, so that kind of diameter. Off the top of my head, I think it's like 17 millimeters, but it's been a while since I designed that. And you can see there the battery, the JST PH connector wire coming underneath. It's quite a neat arrangement. And then the interior layout, you can see there we've got the motors, we've got plenty of space for that pen to go through, and there's no other wires kind of getting in the way there. And as I said, it's balanced quite nicely as well. So the pen holder, I showed you that little mechanism a second ago. Here's a kind of zoomed in version of that. It's quite an innovative design. If I say so myself, it grabs hold of the pen quite nicely. There's not much extra kind of friction required for that. There is a hole on the front if you wanted to put like a little nut or something in there just to hold it in place, but I've not really found that you need that, to be honest. The thing's ever so slightly tapered so that the pen doesn't go all the way through. And it's simple and it's quite reliable. Moves the pen up and down on and off the paper. It's centered in the origin of the robot. It's easy to change the pen, so we can change the colors, and it's compatible with a wide range of pens as well. You can see there. So it's powered by the SG90 servo, rack and pinion style mechanism. Pen rises and falls vertically as the servo turns, and it only needs to turn maybe about 30 degrees. It's the slightest amount of movement just to lift the pen up. Easy to adjust as well, and the pen can be removed easily at the end of the session so the ink doesn't dry up. And it's been designed to be, kind of school friendly. You can take this thing out, it doesn't damage it or anything. You can simply just slot that into place there and just kind of align it nicely like so. So there we go, that's now in place and ready to go. So it's one of the funnest projects I've done, I think, the BurgerBot. So the shims are a really easy way to add extra features to the Picos. Pimoroni do a whole bunch of these different shims, so we've got 2 of them stacked up underneath the Pico. They slide over the header pins, they're stackable, so the BurgerBot has got both the LiPo shim as well as the motor shim. And because they're using different pins, the LiPo shim is really just providing power to the Pico, and it's even got a little on-off button so we can toggle the power on and off very, very simply. And I've made that quite accessible just in the side of the robot there, so you can just hit the button just by putting your finger in there and clicking the little button. and then the motor that goes on the top of that and exposes that to the Pico's pins, and then we can use the Pimroni MicroPython to control those motors as well. So that's the BurgerBot, one of the funnest projects. If you've got a 3D printer, you've got to make yourself one of these. They're so much fun. Okay, just behind me I have this little display. You can just see here scrolling the hello text, and this is, if I can grab this over here, this is a Raspberry Pi Pico. I think it's an original Pico, and this is the unicorn hat. Yes, hat. Pack. I knew I got that wrong. Pack. Packs go on the back, hats go on the top. This is a pack. It has 4 buttons, A, B, X and Y, and it's got a whole bunch. I think there's 7 pixels down by, I can't remember how many across, like 21 or something like that. And it's good enough that we can scroll text across. The reason it looks slightly phased there is just the refresh rate of this and the camera refresh rate are very, very close, so it kind of looks like it's phasing in and out a little bit, but as I look at that, that's nice and solid. And we can change the colour of every single one of these pixels on this unicorn display. So I absolutely love these, and we can do a whole bunch of things with this. So let's go over to project number 5 and have a look what this looks like. Project number 5. Wait for that to load up. Oh, and that one is a video. So this one is the Unleash Your Creativity with a Pimroni Unicorn Pack Text Scroller and Stand. So we'll get to the stand a little bit later on, but you can see if I just whiz through some of this here, we've got quite a bit of information. I've got these slides, so I can show you these in a second as well. But this is a really fun project. If you like working with graphics, it's so much fun to draw out your own fonts and things and have them scroll across. You've got a limited number of pixels to work with, but it's very, very satisfying. And these are quite cheap to buy, these packs. You can just see on there, little message scrolling across there. Subscribe. So let's go back to our slides and have a look at this then. So yes, we can use this to scroll text. We can even, if we use the Pico W, we can scroll text from an MQTT broker or from some other source. So we can use this remotely, maybe to send messages like, you know, tea's ready, that kind of thing. So there you go, 16 by 7 matrix of RGB LEDs, 112 in total. We can control the brightness of each individual pixel, as well as the colour. We've got those 4 tactile buttons, A, B, X and Y. Comes pre-soldered with headers on the back, so you simply just push in the Pico onto the back and you're ready to go. And it's compatible with Raspberry Pi Picos, Pico Ws, Pico 2 and so on. Comes fully assembled, so there's no kind of soldering required, as long as your Pico has headers already on there. So if you've got the H variant of any of the Picos, or if you've soldered your own headers on, you're good to go. And you've got the dimensions there as well, including the buttons. So I had so much fun with this. I designed my own font. I called it Johnny 5 because it was 5 by 5 pixels. We've got 7 pixels available on there, but I thought if I use 5, I could potentially use this for other projects, which I went on to do. So you can create your own font by defining a grid of pixels and then creating a glyph, is what it's called, for each character you want to display. And then you can enter those into a Python file using a list or a dictionary, so we can quickly look them up. So we can define glyphs and then convert those glyphs. Wherever it's on, it becomes a 1. Wherever it's off, it's a 0. We can either add them in like this, where we have a dictionary. Is it a dictionary or list? It's a dictionary, I guess, of 1s and 0s, and then we can store that in a Python file. Python list, it says it there. So it's not particularly efficient on memory, this, because it's actually storing for each bit of the character. It's not storing a 1 or a 0, it's storing an entire byte for each one of those individual pixels that we're turning on and off there. So there is a much more efficient way of doing that, and it's to store it in binary. So if we do that 0 lowercase b in front of the characters, then we can actually store these characters, the actual individual pixels that make up the character, we can store that in binary. So it's far, far more efficient. So you might notice on there that that character, that A character, is actually only 4 pixels across, but it is 5 pixels wide. So I created a font that was proportional. So an I would only be 3 pixels wide, whereas a W could be 5 pixels wide. and we can store the character as well as the we can measure what the width of the characters are. So we've got an uppercase, lowercase, numbers, and quite a few other characters in there. So this is the Johnny 5 font that I created for this particular project. So we've got capital letters, lowercase letters, numbers, and common symbols. So some symbols are really quite hard to do. So doing a lowercase s, for example, we can't quite get the return of the s in those in 4 pixels high, but we can have a go at that. Similar with the E, I think that was quite a tricky one to get that one to look just right. But if you kind of squint your eyes, these look quite readable. And when they're whizzing past on that screen there, they're more than legible. So you can see on here, if I just hold this out there, you'll notice that it's not a fixed font, so that they're not all 5 pixels wide. Look at the 2 L's as they whiz past. So the text looks quite nicer because of that positional, proportional kind of sized font. All the code for that is in that particular project on project number 5, I think it was. So if you like what I do and you want me to make more of these kinds of videos, please drop this video a like. Let me know what kind of Picos that you have, or your favorite microcontroller. If it's not a Pico, you get 10 points minus if it's ESP32. And if you're not subscribed to the channel, please subscribe. It means so much to me. I put so much effort into these videos every single week. It really means a lot to me when I see those subscriber numbers go up. I do go live every single Sunday, come rain, snow or shine, and it'll be 7 o'clock Greenwich Mean Time every single week. Okay, so project number 6, Pico graphics. So Pimroni, when they were creating their displays, such as, I've got this nice 2.8 inch display pack here. So this one goes onto the similar onto the back of a Pico. It's a nice Pico W there. And we can drive this entire display from the Pico. Now, really, it's quite challenging to draw on a display because we can't actually store the display in the Pico because there are too many pixels with too many colors. It's more than the actual RAM that's available on the Pico. So these display packs have some buffers and some technology in there that make this possible. So we simply just plug in our Pico, and then we use the Pico graphics library to draw text, to draw shapes. We could even put pictures on there, JPEGs and so on. And we can also do some more clever stuff like charts, for example. I created an entire library so you could create dashboards using little Pico displays like this. So this does work with the Pimroni flavor of MicroPython. So if I was to just hold down the boot select button on here, unplug this back in. If I now go over to Thonny, it should now let me install MicroPython. And if I click on here and I say that the variant I want is the Pimroni variant, so you can see there, this is a Pico, is that a Pico, original Pico? So this is a Pico, or Pico H with Pimroni libraries. So if I do that, I'll get all the Pico graphics, the motor shim libraries and everything like that simply by just clicking the install button. The reason this isn't baked into like the regular MicroPython is that they do take a tiny bit more memory, a bit more space on your Pico, but not enough that you should really care about that. But for the general case, MicroPython wouldn't include this because this can run on every variety board and not just the ones that Pimroni make. So this is their own flavour of that, and it's pretty much bang up to date with the latest versions of there we go, the latest versions of MicroPython. So this is the Pimroni flavoured one. If we do let's do dir, we should see in there that we get, what would it be? So if I do import Pico graphics, is it? Yep, we can import Pico graphics. If I do dir Pico graphics, like so, you can see there we've got a whole load of new functions that weren't available in the standard MicroPython. So we've got display cosmic unicorns, Enviro Plus, Galactic Unicorn, graphics pack, I2C, OLED 128 by 128, Inky frames, and so on. We've got a whole bunch of different types of displays. So let's have a look at what those displays look like. So we've got the LCD graphics display. So LCD is liquid crystal display, and we can simply manipulate the image. This is kind of behind the scenes by manipulating the light properties of liquid crystals. We get a really nice high and bright contrast between the sort of dark and the light. They're typically backlit as well, so you get that nice kind of glow. They look very retro. And there's a whole wide range of sizes and resolutions available. It's a maturing technology, results in a very low cost, so we can put these together quite cheaply. So this is the Pimoroni graphics pack. And you can even wear this, it's got like a lanyard thing, so you can wear this around your neck with a battery pack on the back as well. Then we've got the TFT, or thin film transistor. So this is a subtype of LCD where each pixel is attached to a transistor and a capacitor, and that actively maintains the pixel state while other pixels are being addressed, thus improving image quality. And the benefits of this is the image quality, the refresh rate over traditional LCDs, supports a wide range of colours, and it's ideal for resolutions needed for like laptops or TVs, for example. So the Tufty is the TFT, Tufty 2040, that one came out quite a while ago. They've since done a Tufty W, which is the wireless version, and you can wear this as a badge to like a conference, and you can have it displaying all kinds of nice colour graphics and things. You've even got some buttons on there as well to control that. And then there's the e-ink displays. These are like the Kindle type display where it has a display that if you remove the power, the image will stay on there until you change that image, and it can stay on there for over a year. I think I've got some original inky fat displays that still display the date of the calendar when I was first playing about with that. So e-ink, or electronic ink, creates images using tiny microcapsules filled with positively or negatively charged particles. And the benefit of this is ultra low power consumption, only uses power when the display is being updated. Excellent readability in sunlight, so you can get a really good viewing angle on this, and it mimics traditional paper, reducing eye strain. The only downside to these e-ink displays is the time it takes to update the display. It can be like 20 seconds on one of these colour displays, for example. But the image quality you get out is pretty good, and yeah, you've got that very, very, very low power usage. And then finally we've got the OLEDs, or organic light emitting diodes. So these emit light when electricity is applied to the thin organic films, and the benefits of this is exceptional colour and contrast. Very thin, flexible displays are possible with this as well, and you get that very fast refresh rate and good viewing angles. So Pimoroni also do these SPI displays, and they connect into the breakout garden environment which Pimoroni have. So the different types of display technology, LED matrix. So this is where we have individual LED pixels in a matrix array, and if you have enough of these, you can create a great big display like they would have like a stadium, for example. And LED matrices have an array of LED pixels for the display. They can be single or multicolour, like single black or white, or multicolour. And they're very high brightness, can be seen in direct sunlight, excellent for dynamic content and animations. That you can see the one just behind me, actually, that's an LED matrix there, just running a little display, computer display thing. Very robust, long lifespan, and different types of sizes are available. So Pimoroni do the unicorn hats and packs like you've just seen there. They do the stellar unicorns, which is the square ones, the galactic unicorn, which is the very long one, and the cosmic unicorn, which is kind of a larger version of the stellar one that's just been displayed there. So Pico Graphics is a graphics library for Pimoroni displays, and it works the same across all display types. So it doesn't matter what kind of display you've got. Use a Pico Graphics to put text or colours or pictures on the screen, it'll work the same. We simply just have to tell it what type of display we're using. It will figure out the rest. As you can see there on the right hand side, we've got the cosmic unicorn, stellar unicorn, and the galactic unicorn, as well as the little unicorn hat mini, the little unicorn pack down there, the inky displays, as well as the display 2, I think that one is 2.0. And we've got the Tufty at the top there, as well as the LCD graphics display. So you can do so many cool things and fun things with that. So if I just jump back to over here, you can see we did an entire video on how to, sorry, go to the right project, number 6. So it sometimes does this. I think the Pico Note 6. I don't think it's caught up yet. I use Cloudflare to do some caching, and sometimes until the cache is caught up, it sometimes ignores new pages. So this video here, how to draw graphics with MicroPython and Pico graphics, is an entire video on how to do exactly that. We talk about all the different theory, like the bit depths. We talk about how to animate a display, converting images, how to create images with GIMP, which is that GNU image manipulation program. Save it into these .pmb, which we can open up in MicroPython, and that means we can create our own graphics very, very simply. And yes, we go through all the detail of how to do that in that particular show. So if you want to learn how to do that, check out project number 6, I think that was. Okay, so next up we have project number 7, the birthday card. So I created a birthday card that was very special for Alex's 21st birthday. So it contained a Raspberry Pi Pico. It had a touch button on there, which would start off the whole animation sequence. And there's a little buzzer that will play the happy birthday tune. And there's a little 5x5 pixel display there that can then scroll some text across. So that you can see on the screen there, I actually put another sheet of paper on top of that with a little arrow saying put your finger here, which was just over where you do the touch sensor. And the battery pack would also provide the power for this pack as well. You can see there's a 3D printed piece that holds all the components in place, and then it's just like a regular birthday card around that. So that's project number 7. So the wiring for this is pretty straightforward. We've got the touch sensor, which is a capacitive touch. If you put your finger over this capacitive touch sensor, it will detect that there is something there, and you get a simple 1, so we can read that in a loop. The buzzer is connected to pin number 9, GPIO 9, and it's not a speaker, it's a buzzer, like one of these. You get these active or passive displays, active or passive buzzers, so it simply just has these 2 pins on it. And these can be quite loud. There's no volume control on them, unfortunately. You probably just put a resistor on there if you wanted to sort of quiet it down a little bit. And then the RGB LED matrix is an I2C device, so we simply need an SDA, a data line, and a clock line. So GPIO 2 and 3 provide the the I2C for that. And yeah, the battery pack has also got I think it's a LiPo Amigo Pro, just to provide some recharge battery capability on the card, just so that it would definitely work on the day. So if we want to go to, I'll just back up one little bit because I want to carry on with that one. So if that one is project number 7, let's go over to project 7 over here. Let's try that. Hopefully that will work. Let's try that again. Pico number 7. There we go. So there's a project there for the birthday card that talks you how to build this, all the different components that you'll need, the wiring which we just looked at, all the different components, the assembly, and there's the 3D printed insert there as well, and then all the different parts of the code that you'll need, the buzzer code demo, the cake.py, so that's a little icon of a cake. The font is the Johnny 5 font that we looked at earlier. Touch.py is the kind of the driver for the touch display, the touch sensor. And the scroll.py is how we can scroll some text on that 5x5 little matrix. And the happy_birthday.py is a program that kind of brings it all together and makes it work. So if you want to check that one out, you can go over there to project number, was it project number 7, that one? Yes. Okay, so let's have a look at project number 8. You might have just had a quick sneak peek at that one a second ago. So this is OpenCat or PicoCat. So this is a robotic cat using a whole bunch, I think there's 11 servos that we need for this, and a PCA 9685 board. So a PCA 9685 board, I wonder if I've got one of those to hand. This is a servo driver which allows us to plug in up to 16 servos and control it with just I2C with just 2 cables. So really, really simple to control a whole bunch of servos on there. We can attach a couple of wood screws with the 3D printed parts to build up the actual cat itself, and all the 3D printable files, they're all available on Pico 8, which we can have a look at now. So if I go over to Pico number 8, There we go, PicoCat version 2. So this has gone through quite a few different iterations. The later versions, I didn't use just the Pico, I used the the Servo 2040, which is a Pimoroni board, which kind of has that PC 9685 board built in, so that all the headers are just on the single board. But we can actually drive this with a standard Pico and that PCA 9685 board. So there's a whole series of videos that you can watch on how to do this. And this has now become a commercial product, I understand, by Pet.io, called Bittle or Nibble. There's a couple of different variations of that. And yes, it's a 3D printable open source cat, and we can program it with MicroPython with my code, which is below. So there are all the different videos, and there's quite a few different blog articles on that project as well. This is a really fun one to do. You can get yourself started by clicking on that code as well, and you'll find everything that you need in that little class. So you can follow along with that video, build yourself a robotic pet cat. So very, very fun video. So OpenCat, like I said, we can use the Pico if we just want to run the standard kind of demo code. If we want to make this remotely controllable, we'll probably need to use the Pico W, because we need to have that Bluetooth or wireless capability, and it'll probably work quite well with, let me just grab this, these little gamepad remotes that I've created as well. So they use also a Raspberry Pi Pico W, and they have a little screen and a whole bunch of buttons, and we can pair this with another Pico W and then send it the commands to make it move up and down, left and right, all that kind of good stuff. So if you're interested in that one, definitely drop me a comment up below, and we can expand that cat to work with that particular remote control there. They will be for sale very, very soon. I've got a couple of weeks off around Christmas period, so I'll be looking to set up the shop then. So this also includes this upgrade, the MPU 6050, which is a gyroscope accelerometer, which means we can measure what position the cat is in. Is it sort of on its side, on its back? Is it upright? Is it leaning a particular direction? And we can adjust the servos until it's maintaining its stance correctly. And we can even include some nice servo easing. We can ease in, ease out the motion, easy ease, and that means that the servos don't sort of jankily move, they move very, very smoothly, and we can build that into our code as well. And the upgrade also included some upgrades for the servos. So instead of using the SG90s, which were plastic, we use the MG90s, which are Metal Gear. So you can see that the components we've got 4 legs, each has 2 servos. We've got the tail, which you can use for balance as well. We can put a weight on that to help it sort of swing around and move. There's the eyes are actually a rangefinder, an ultrasonic rangefinder. We've got the MPU 5060 for the inertial measurement unit, the Raspberry Pi Pico, and the LiPo battery as well to power the whole thing. And the servo layout looks like that. We've got the front left foot, the front left leg, the back right leg, back. I think I've named some of those incorrectly there, because honestly it doesn't roll off the tongue very easily when you put these together, but you get the general gist there. There's a lot of servos involved in this. It's not a cheap project to do, unless you can get hold of the servos quite cheaply, and then in that case it's quite fine. And this is a prototype, so quite good for learning how to make an animal walk, what the walking cycle looks like, and making it balance on potentially 3 legs at a time. So very, very fun project. So project number 9 is a plant monitoring system. So we can measure soil moisture, we can look at light levels with light sensors, we can, for extra points, even include the ability to water our plants. So I've designed some 3D printable pots that work with this project as well, and this is a project that I get out every single spring when I want to start growing some chilies. And the chilies we grew this year were absolutely mind-blowingly hot. They were really tiny, but man alive were they hot. So this is my little factory for making that, and I've simply got a Tupperware, really useful box with some water in there. The tubes go into there. The tubes are connected to a little pump, and the pump is controllable by the Pico. So we can basically just measure the soil moisture for each of the different pots, and depending on what that soil moisture level is, we can say squirt for so many seconds some water in there, check that that's okay, and then we can leave it for another couple of hours until that moisture's been absorbed or evaporated out the pot. Now you can use the Pimoroni Grow, which is one of the kits that they have for this, but you can also just use a regular Pico and some resistant. I think I have some in one of my little pots up there, and essentially it's a probe. I can't see them off the top of my head, so I'll leave them be. Essentially it's like a fork with two pieces of copper, and we can measure the resistance between those two pieces of copper, and we can read that in as an analog value to one of the ADCs on the Pico, and that means that we can then measure what that resistance level is and therefore map that to whether there's lots of water or not very much water in the actual soil. And the light sensors, there's a number of different ways we can do that. We can simply get a light sensing component, and again that works off resistivity, so the photo resistance will change based on the amount of light that's in there, and that means that we can actually measure, is it night or day. Maybe we could have this on like a lazy Susan so it could rotate round to get a better or more even sunlight depending on where this is. So that's Pico number 9 project. So lastly, project number 10 is the driving LED strips. This has got to be, I think, one of the funnest things you can do with a Pico is to control LED strips. It's so visual, so instantaneous, and so much fun you can have with this. So there's two different types of LED strip. Fundamentally, there's probably many different types, but fundamentally there's two different types. There's WS2818, they're the most common type, and then there's the .101 type. One type uses 4 cables, so we've got the voltage in to drive the LED strip, the ground, and then we'll have a clock and a data. And the other type just has 3, so it doesn't need the clock, it just has the data. And we can actually address each individual pixel on that LED strip and change it to a different colour very simply. So I made an RGB LED dog coat. I think it's actually just off camera here. Here it is. So this is a dog coat that my dog Archie wore for this particular thing. You can see it sort of bends around like so. And this went hand in hand with this little saddle that I created for Archie. So this piece of strip here can go through underneath his little stomach and sort of velcro into place. And on this saddle, you can see there we've got a Pico W, so we can control this from our phone. We have the little LiPo controller there, so this will control the battery, which is just sat in this little pocket here. And we also have a plasma 2040, which controls the RGB LED strips. So you can see there we've got the little connector for that as well. And this is such a fun project. We got a lot of attention there. I made sure that it didn't burn him or anything like that before I put that on. We had lots of different testing going on. But essentially we can make the dog coat animate all kinds of different patterns. We can even scroll text across there, and we can make it accessible via a Wi-Fi hotspot, so we can control it from our phone as well. So much fun. So that's Pico 10. Let's go and have a look at that one. So that's Pico 10. Again, if we just need to just type that twice, let's do that. And this particular one is how to power lots of LEDs using a single Raspberry Pi Pico. So this is a tutorial that Raspberry Pi themselves have done, and it kind of shows you how you need to do that. So we simply take the 5 volts and the ground from the Pico, and then we simply have one cable on here to control all of the LED strips. So these do typically require quite a bit of power, and that's why I've got the Plasma 2040 driving the actual LED strips. You can just use one Pico to do this, because it's only the data that's being powered, if you like, by the Pico. And we can use this programmable I/O to control very rapidly the LED pixels. So that's how we would do the programmable I/O. So we can output X32, we can move the pins, and that piece of code there will pulse through and set the RGB LED pixels for us. So if you want to check out that one, you can go to Pico 10 on kevsrobots.com, and even works with the NeoPixel rings as well. So that is such a fun project to do. So there's Archie with his little dog coat on. So the way that these work, like I said, we can either have 4 pins with the data and the clock, or just the 3 pins where we just don't need the clock pin. And then each individual LED has, you can see that little chip that's next to it. That's how it knows which pixel is being addressed. And we can even cut these strips. So if we don't want to have like a really, really long one, we can actually cut these like specially marked areas there. And you can even solder these together if you need to. So on that one, I actually created a strip that kind of goes in that kind of direction. It kind of snakes its way around. I've got a example of it in a second, I think. And there's the code to control an LED strip. So we can simply import NeoPixel. We can then control what colours we want to send there, and then we can fill the strip, write to the strip, and then cycle through again. And each time the colours will, it'll go through each of the different colours. So that's red, green and blue. And there's the actual code that I've just held up, so you can see it a bit better there. So there's the LED strip. I then soldered the wires there, so then the pixels are addressable in that direction, and it kind of snakes its way around. So that did mean it's quite interesting in the code. I had to come up with an algorithm. If I wanted to say address that pixel there, I would have to say, you know, X and Y, what column is that and what X is that. And because of the way it stripes around, it took a little bit of thinking about how to get that to work. But really works well. The larger surface area of the coat for gluing really helped with this. I've got these little spaces just to make sure the LED strips stay nice and aligned, so we could scroll text and so on. And also they're on the outside of the coat, so if it did rain on this particular one, the thing wouldn't work. So we had to make sure it was nice and light, as that was nice and dry, I should say. Cool, so if you want to learn more about how things work, I've also got this how it works section on kevsrobots.com, so kevsrobots.com/howitworks. And we cover off things like RGB LED strips, servos, PID controllers, batteries, servos, stepper motors, the lot. Everything is included. If there's anything that's missing from there that you'd like to know something about, let me know in the comments and I'll definitely write that one up as well. Now I did say that there was a bonus one, so project number 11 is Pico stands and enclosures. So I have built some Pico stands. I've got one just here, which is actually on the, let's go full screen on this one. So you can see here, there's a single print, it prints as you see it here from the bottom up. You can also print it that direction if you want that orientation, but this way is probably the easiest way, and it doesn't require much support because it's at a 45-degree angle, and 3D printers quite like that. It's a kind of magic angle for that. You can see on this one we've got the kind of space for the cable to come in, and on later iterations of this there is actually a hole on the back, so you can push with like a pen or something to reset the Pico, because otherwise you have to sort of unscrew those little screws. These are just like little nuts and screws, and that's just simply got the Pico unicorn pack installed on there. But these work really well. They've got a really nice viewing angle on them, and they're perfectly designed for Picos. There is actually a variant of this for the full-size Raspberry Pi and also for the Raspberry Pi Zero. So there's actually 3 different stand types that you can download. So if we go to Pico 11 project on kevsrobots.com, we can have a look at those as well. Oh, good grief, Pico 11, there we go. And I even did a video on how to build these. So that one is actually, you can see on that little picture there actually. I zoom in on this one. Sorry, I'm showing you this and you can't actually see it. So there we go. So there's the little display pack. There's a Raspberry Pi Zero running the Enviro Plus, the little environmental particulate sensor there, and there's a full-size Raspberry Pi with the Sense hat on there as well. So that's available if you go to kevsrobots.com, Pico 11 as the project number. And you can download the stands just there. Very, very simple. If you like those, definitely buy me a coffee. That always helps. And you can see there's a little gallery there of them as well. This one even works with the plant monitoring one. So that little Grow Hat Mini, you can see that's on top of a Raspberry Pi Zero, and it's got clearance for the cable and everything, so it's perfectly designed to work with the Picos as well. And you can see there the little cables going to each of those, the different soil sensor things as well. So there you go, you can download those for free. Pico 234 even works with Raspberry Pi 5s, and there's the Pico Zero and the Pico stand. Pi Zero stand and Pi Pico stand. There we go. Cool, so that is 10 projects for you to enjoy and get you started with your brand new Raspberry Pi Pico. So if you like these hats, you want to help support the show, you can get yourself one of these amazing Robot Maker hats. They look really cool. I wear mine all the time. Tied my baldy head. Keeps me nice and warm in winter as well. So yeah, you can help support the show by going to kevsrobots.com/merch. And we also have a Discord community. I fixed the Discord link, so that should be working now. So if you go to kevsrobots.com/discord, you type in your email and your name, it'll send you a link via your email account, and you'll be able to get yourself logged into our Discord server. It's a really fun environment. There's loads of people sharing pictures of projects they've worked on, helping each other out. It's a really nice environment, actually. And if you want to follow me on social media, I'm on all the different social media channels. I'm at Kev McAleer, threads.net. On TikTok, I'm at Kev McAleer 6. I'm on Instagram at Kev McAleer. I'm on Kev's Mac on X for now. And on Mastodon, I'm at Kev's Mac at mastodon.social. That seems to be one of the nicest places, to be honest. And there's a lot of people going over to Blue Sky. I signed up quite a while ago. So at kevsmac.bsky.social if you want to find me on Blue Sky as well. My recommendation would be Mastodon's probably like technically and politically the best, most neutral, because you've got most control. I think B-Sky and Threads are kind of owned by a master company. Mastodon is like truly federated, so that's one I would recommend people go on. But Blue Sky seems to be pretty popular. I post to all of those networks. So, and if you want to join me and get your name in the end credits, you can do that by going to kevsrobots.com/coffee, and you can get your name in the end credits. And if you want to drop me a super thanks or a super chat if you're watching this live, you can do that as well. So thanks Ford for buying that super thanks. I really appreciate that. And you can also join the YouTube membership program. We also have a Buy Me a Coffee membership program if you want to use that instead. Both of those work. I'm happy with both of those. So let's give a shout out to our supporters right now. So coffee-wise, we had somebody that wanted to be anonymous donate a coffee. Adam bought one. Thank you for that, Adam. As well as John. Thank you for that. And then we've got the members on the Buy Me a Coffee side. We've got we've got Andy, we have Shemi, we have Jeff, we have Steve, we've got DN Corty, Marlene, and Tom. And then on the YouTube membership side, we've got a few new members on here. So we've got Michael Emerson, Steve Phillips, we've got Dale with Hybrid Robotics, and we've got Ford, we've got Bello, Oxford 39, Littleback, Paul Cummins, we've got Johnny, we have Hans from Cheerlights, we've got Prem Kumar, we have Steve Cross, John Paul Jolly, Alistair Ware, Cassie, we have Tinkering Rocks, Johnny Bates, and of course we have Tom as well. So thank you to everybody that's subscribed to the channel. I really appreciate that. And that's everything for today's show. So if you're watching this on replay, you'll see another video over here that I definitely recommend that you watch. Nudge, nudge, wink, wink. And you'll be very happy when you've watched that video, no doubt. So at this point in the video, I'll say thank you so much for watching, and I shall see you next time.